Hi everyone, nice meeting you again. Now guys, we are going to complete our next lesson, which is talking about the reflection of light, to complete the last point of this session, which is refraction of light. So the title of today is refraction of light. Refraction of light. Of light. In the case when we was talking about the reflection of light, we said that the light bouncing back or returning back, but the light always returning back in the same medium, meaning that you are seeing your image in mirror when you are standing on air. Even if you like to see your image in water, you are going to take the mirror with you below the surface of water. But what will happen if you have a light in your hands and you are looking to it below the surface of water, meaning that in this case you have two different transparent medium. One of them is air, the next one is water, or one of them is air and the next one is glass. Let's see our images here. Okay, this is a prism, guys. It's a prism. It's a kind of glass, thick glass surface. When you use your torch, laser torch, to see what is going to happen to the light when it crosses from air, the first part air, to the glass, then back again to air, you can see that the light, which will never travel in except in a straight line, is going to look broken. Let's see the next image. The same with glass and the same with water. The blue color is the color of light ray. When it crosses from air to glass, it will look broken. From air to water, it will look broken too. Let's look here, guys, to the cup of water. Yes, here. We can see here, when you put a pencil inside a glass of water, you can see that it's look broken. Why do I see that? It's due to the refraction of light. So the pencil look broken due to the refraction of light. But why the light it change, or the appearance of pencil look like this? We can explain it. Now you are running on the beach. You are running on beach, and suddenly you moved towards water. So you are here running on the beach, then you change your direction and go to water. Are you going to be faster on the beach or in water? You are absolutely right. You are going to move slowly in the water. If you want to reach to your father is waving for you. Come here, dear, come here, come to the water, play with me, swim with me. And you try to reach to your father. If you wanted to move in a direct direction, in a straight line, you will never be able, because the water is going to change your direction. The same idea happened with the light. When the light wants to cross from air to water, from transparent to another transparent, its direction is going to change. Let's write the definition of light refraction. Light refraction, it is the change in light direction when it moves from one transparent one transparent transparent medium to another. For example, the first transparent medium is air and the second one is water. Okay guys, why did this happen? We can explain it by using the three states of matter. Guys, we have three states of matter and we have drawn it so many times this term. One of them is solid. The other one is liquid. The last one is air. Here is the molecule of solid. They are stick together, meaning that the light, and they are opaque. The light can't move through them. If the light ray want to move through them, it will move slowly. It try only to move in that little piece or little spaces that the light can move through it. So it will be slow. But in water, the molecule of water is away from each other. So it can move through it, but according to the molecule. If the light ray face a molecule, it has to change its direction to move during the spaces only. In air, the molecules are so far from each other, so the light can transfer through it without being broken. So when you change the media from solid to liquid, from liquid to air, it will cause the change in the direction of light. Here, the density of molecule is high. Density is high. So the light moves slowly. Here in air, the density of molecule is low. There aren't many molecules, so the speed is high. Okay guys, and here a new definition that we are going to use it, which is called optical density. What is the mean of optical density? It means the ability of medium to refract light. Ability of medium to refract light. So you have seen in solid, due to the high intensity, it has high ability to refract light. It has high density, so it has high ability, high ability to refract light. But in case of air, it has a low density, so it has a low optical density. Okay guys, let's return back here and see what we can use. Here guys, the 5 parts that we need in our session. Light refraction, and we have mentioned the definition, optical density, and we have mentioned it. Now we are going to talk about the law of light refraction. So the next point, law of light refraction. Law of light refraction. Law of light refraction. Let's see what is happening here guys. Divided into 3 parts. The first part of them, here is air and here is water. If we wanted to know what happened to light when it passed from air to water, so the air fall here with incident light ray, like the light reflection. So the ray that is come and fall down the water till it touches the water surface is called the incident light ray. And that one which is going to be broken down, it's the refracted light ray. Okay, in air, density low. the angle here is high or large too. If you look to the angle, you find it large. But in case of water, its density is more than air. Density high, speed low, and the angle too is small. Angle small, like this. It's smaller than the angle of incident, and this ray is called refracted ray. What about, or in case of, if we move from water to air? Now let's make it larger. I'm going to move from water to air. First of all, we are going to draw the normal line. You can see the angles. Here is the incident light ray. Water again has high density. The speed of light in water is slow speed, and as the speed is slow, the angle too is small. Angle small. So you can find that there is a direct relationship between the speed and the angle between the incident light rate or refracted light rate. Incident light rate. Okay, here is the angle is small. But now we have, for example, a lamp or a laser torch under the surface of water. What will happen to the light ray when it passes from water to air? Let's explain air. Air has low density. Air has high speed. The light can move in high speed, so the angle is large angle. So the angle is going to be like this. And here's the first angle by which the light moves from a place to another is called incident. But the light ray after refraction is refracted light ray, and the angle is called the angle of refraction, and here is the angle of incident. So if you move from a medium with low density, it has high speed and large angle, and this one has low optical density because it doesn't have a high ability to refract the light. But in case of water, which has high density, the speed of light is slow and the angle is small, it has a high optical density. So here is high optical density like its density, and here low optical density like its density. So the density of medium is the same optical density of medium. If I wanted to move like light refraction, and I moved as normal, meaning that I look from here. Here is my eyes. I looked like this, not like this, or not like this. What can you see? I can see the lights that come from up to down without any change, because the incident light angle equal the refracted light angle and equal 0. There is no refraction. There is no refraction in case of perpendicular light ray. If you want to catch a coin under the water surface, you can look perpendicularly on the water surface. If you wanted to know the direction or the position of a fish under the water surface, look to it in a perpendicular way. Okay, guys, but we have here many natural phenomena related to the refraction of light. like the splitting of light. From the properties of light as that it's split into 7 colors. Why did it split? If you look to the glass prism, you are going to find it's made of glass. When the light moves from air to that glass prism, it's going to split. Why did it split? Because the speed of light in air different than the speed of light in glass, and the optical density is different too. That is the main reason. Here we can see that there is someone looking to a fish, but he can't be accurate to know its position. Uh, you can look to the ray with the red color. The red color is the real place, the real position of fish. But that one with yellow color is what your eye see, because your eye see the extension of the light ray. So the position of the fish, which is the extension of the yellow color, is not the right position. You are looking inclined, meaning that you are looking to the water with an angle, not perpendicularly. So you can't detect the right position of the fish. You will be completely wrong. To find it, you have to look at it perpendicular. So to find a coin, to find a fish, you have to look perpendicular. The last part that we are going to talk about it is the mirage. Mirage is a natural phenomena. You may meet it in the desert, in night, in daytime, when you look from far distance and find something like water. But you know that it's not water, it's a desert. There is no water. What is it? It's a kind of combination between light reflection and light refraction caused this phenomena. So you can see image of many things on the road without the presence of water, and you will imagine that there is a water far away from you. When you reach there, you will not find any water. If you are thirsty, you are not going to drink it. So guys, if you see something like this, if you can't detect the right position of fish, if you can't detect the right position for coin, if you see mirage, this all of this, or a broken spoon or a broken pencil, meaning that it's due to the light refraction. And if you have any kind of this question as a give reason, you are going to answer using this part only, due to the refraction of light. We have finished our lesson today. Thank you guys for good listening. I'm waiting for you for the next session. Hope you are all well. Thank you very much, guys. Bye.